Okay, guys, so let's get started without any further ado. In the last class, if I remember correctly, we talked about the IPv4 addresses, properties of IPv4 addresses, again, how do you convert any binary number to a human readable decimal number. And along with that, we tried to figure out what was the first type and the last type, what is the range of IPs. Today, we're going to talk about the sequence of IP addresses and something called, again, classes, class A, B, C, D. Okay. So firstly, when we talk about the sequence of IP addresses, guys, there are two simple rules to understand the sequence. Rule number one is we always start with the rightmost value. What I mean by that is if this is the first IP, 0000, the next IP would be 0001. So the rightmost value will always increment by one or increase by one. So you have 0001. After that, you have 0002. After that, you have 0003, then 0004, then 05, then 06, then 07, 08, 09. Keeps on going all the way up to 0250, 251, 252, 253, 254, and 255. Now, once you reach the maximum value here for any octet, 255, then what happens is that 255 cycles back to zero. So that's rule number two. Only after the rightmost octet has been completely filled, then we go to the left value and reset the rightmost values back to zero. So once this reaches 255 here, we reset it back to zero. And the left value, the zero now changes to one. So the next IP is 10. So after 10, don't directly jump to 20 again. That would be wrong. Remember, rule number one, always start with the rightmost value. So after 10, you have 11, then 12, then 13, then 14, 15, 16, 17, goes up to 1255. Then you have 20. Okay, so this 255 cycles back to zero again. And this one changes to 2. So if you notice, the cycle is repeating here. 00 to 0255, 10 to 1255, 20 to 2255, 30 to 3255, 40 to 4255, 50 to 5255. Like that, the cycle keeps on repeating. And somewhere you'll have 2550, 2551, 2552, up to 255, 255. Now, both these octets are filled. What happens? They cycle back to zeros again. And this zero now changes to 1. So whatever cycle repeated here from 000 to 0255, 255, same cycle repeats again from 100 to 1255, 255. Okay, so again 00, 01, 02, 03, up to 0255, 10, 11, 12, 13, up to 1255. This goes on and on. And somewhere you'll have 12550, 2551, 2552, 2553, 255, 255. So then this one changes to 2. As you can notice, the cycle repeats 200 to 2255, 255. Then after that, 300 to 3255, 255. Then 400 to 4255, 255. And finally, the cycle goes on all the way up to 025500 to 0255, 255, 255. So whatever cycle repeated here all the way, okay, from again 0 to 0000 to 0255, 255, 255. Same cycle now repeats after that from 1000 to 1255, 255, 255. From 2000 to 2255, 255, 255. From 3000 to 3255, 255, 255. And finally, from 255,000 to 255, 255, 255, 255. Here's the first IP, and here's the last IP. So if anyone were to ever ask me how many IP addresses are there in total, you would have to multiply 255 4 times. So 255 into 255 into 255 into 255. Since there are 4 octets, each octet revolves 255 times. Okay. And that would give you 4.3 billion IP addresses. So back then, in the era of 1950s or so, when IP addresses were invented, they thought 4.3 billion IPs were more than sufficient. But fast forward to 2023, population itself is 8 billion people, and 4.3 billion IPs would not be sufficient, right? So that is why they came up with 2 solutions again. Solution number 1 is called NAT, which stands for Network Address Translation. What it basically means is you have divided these 4.3 billion IPs into something called classes, class A, B, C, D, and E, and then into something called public and private IPs. Okay. So if I show you this with a diagrammatic representation, this is how your 4.3 billion IPs are categorized. So you have, let's say, this huge box here represents the 4.3 billion IPs. IPs in the IPv4 range. Okay, so these 4.3 billion IPs first are divided in 5 columns. Okay, so you have something called classes. So there are 5 smaller boxes here. Class A, Class B, Class C, Class D, and Class E. So each of this is known as a class. So this is Class A, Class B, Class C, Class D, and Class E. Again, each class is divided into 2 subcategories. So class A has some IPs in the private IP range and some IPs in the public IP range. So you have some public IPs and some private IPs. Don't worry what they are. I'm going to explain that in a bit. Okay, class B also same scenario. Some of them public and some of them private. Class C as well. Some of them public, some of them private. But in class D and class E, there are no private IPs. All of them are public IPs itself. Public and public. In class A, B, C, you have both public and private. Same thing, public and private. So this is how your IPs are categorized. The whole 4.3 billion IPs are categorized. Okay, in these 5 boxes with subcategories. Now we'll talk about classes in the next session, guys. Class A, B, C, D, and E. Today we're going to talk about public and private IPs. Okay. Before we do that, can I clear the drawings, guys? Can I erase these drawings? Sam, ready?
Yeah, sure.
Right. So again, as mentioned, guys, you have these 2 categories called public and private. Now, each of these categories is provided by a certain, you could say, a certain different person or organization. Now, in our home network, we usually have a Wi-Fi router. So let's assume this circle represents the Wi-Fi router that we have. And this Wi-Fi router is connected to multiple internal devices. So you could be connected to your laptop. 1 second. Yeah. So you could have your laptop in your network. You could have a smartphone in your network. You could have a smartwatch. Again, you could have a smart TV, whatnot. Okay. Each of these devices is internally connected in your intranet, or you could have called as as mentioned, the private network. So your router also gets a cable from outside your house that is usually given to you by the ISP, Internet Service Provider. So here we have the ISP. And this ISP provides a cable, an optical fiber cable or something, which reaches from the ISP to the router. Okay. And this cable is what provides the public IP here. So public IPs are the IP addresses used by the ISP, Internet Service Provider, which is given to clients to access the internet. So with the help of a public IP, you allow your router to communicate with the ISP over the internet. That's why we need a public IP. Internally in your home network, there you have the private IPs. So again, over here, this could be my private IP1. So router could get PR1, private IP1. Your laptop could get PR2. Phone could get PR3. Smartwatch could get PR4. And device, smart TV could get PR5. Okay. So when I want to connect to google.com, let's say there's a server somewhere on the internet called google.com over here, www.google.com. So when I want to connect to this website, google.com, from my phone, this is how the packet would travel. So from my device, first the packet comes to the router over here. So internally from my phone to the router first. From the router now, it jumps from one interface from internal network to the external network. Okay. And after that is done, then it goes to the ISP, Internet Service Provider. And from the ISP, it reaches the target system. So when you're accessing the target here, it knows exactly who's accessing it, okay, and what IP address they're using, and what is their location information. Okay. But again, this is what your normal traffic looks like in real-time scenario. From your phone, it comes to the router first. From the router, it goes to the, again, as mentioned, ISP. And from the ISP to the target website. This is how normal traffic should look like. Okay. Any questions or doubts up to this point, guys?
In case if I don't connect router and directly connect with the ISP. So
yeah, that could also happen with mobile data. So your SIM card gets the connection. So without the Wi-Fi router, your SIM card allows you to connect wirelessly via satellite to the ISP's network. So the mobile data that you're using usually happens with that mobile data or SIM data, or as mentioned, the signal being sent from your SIM card to satellite and from there to the target website. Is that clear?
okay.
Sorry, Kesh, what was the name again? Sam, sorry.
Ravi.
Like that. Yeah, Ravi. Any questions, Ravi?
Yeah.
Yeah, go ahead. Let me know what the questions.
No, yeah, that was my question.
Okay. So again, as mentioned, guys, these public IPs are the IPs provided by the ISP to connect to the internet. So ISP, Internet Service Provider, is the organization which supplies you public IPs to access the internet. Private IPs, on the other hand, are used in your intranet. So on the outside, this is your internet here. Okay, and internally in your private network, that's called your intranet. INTRANET. Intranet is your local home network, okay, or your local organization network. Internet is a public network where anyone can send traffic to any website, right? So in my intranet, each of these devices will be using a private IP. And over the internet, each of the devices which stands outside your network will have a public IP for that. Is that clear? Where do we use private and where do we use public IPs? Any questions regarding that? Hello? Ravi, San, any questions?
Yeah, I'm good from my.
All right. So we also have to talk about the classes, how these classes are different from one another. Why do we have 5 separate classes? Why not just one single class and make the task easier? So we'll talk about all that in the next session, guys. So that's nothing further for our session today. If you have any questions, you can let me know, San, or you have my personal number. I've shared that in the chat box yesterday. Just in case if you still don't have it, here's my number, 98499847778. So if you have any queries that you would want to personally ask me, you can let me know on that WhatsApp number. Okay. So yeah, that's it, guys. Nothing further. I'm going to exit the session now. And I'll see you tomorrow at the same time. Bye-bye. Good night. Again, just demos, guys. That's why we're taking shorter sessions. Once I get a confirmation on the payment and once the link changes from Monday or so, we take the longer sessions, 40 minutes, 45-minute sessions as well. Bye, Ravi. Bye, Sam. Good night. See you tomorrow.
Bye. Thank you.
Thank you.